thing. All right, we're doing a coin flip simulation, and I wrote at some point, I thought, oh, I wonder what the difference in speed is between Python and Java and C++ or something like that. It's actually on my GitHub, and what I discovered was Python's the slowest, next is C++, and the fastest was actually Java, which doesn't mean the languages are faster. It probably means that the random library is more efficient than Java. It's my guess, but maybe not. I don't know. I just did it because I thought it was fun. So there's our randint, which we have used before to generate random integers. So I'm being specific. I'm saying from the random library, I only want the randin piece. Here I'm just importing everything. And I did this on purpose just to show the different ways to import. So here I'm importing time and I have the whole time library. Do I need that? No, I could have just done from time import time. Is it going to make any difference with our programs? No, but if you get a big giant one, it might make a difference. Okay, so now we're keeping track of heads and we're keeping track of tails. We're getting an integer, how many rows? So one way to time a program is to say, here's the current time, and it captures the time in milliseconds. And then at the end, once we're done, it captures the time again as no, where's my capture the time? Yep. Oh, there's the time. There's our time here. At this point, we subtract the previous time and we have the elapsed time. So we're looking for how many times heads. Okay, it doesn't make sense unless we do this. So we're going through 10 times. Each time we're flipping the coin 100 times. How many times do we end up with 47 heads or 47 tails? And here's how we count. If it's equal to 47, we add it to this. If it's equal to tails, it's equal to this. And let's run it just to see. This was just, I thought, interesting. How many times do we want to roll it? Let's try 10. Well, that's not too bad. 0.0029 milliseconds. Yeah, that's pretty fast. There's only one. Well, is our, what do you call that? Sample area very big? No. Let's make it bigger. Yeah, so now we're getting a different sampling area. It took a little bit longer. And I've also thought, if you do this in those three languages, it might have to do with how the random number generator works. It could also just be how fast it displays to the terminal, but I haven't tested it without displaying to the terminal yet, just to see. This is just one of my little projects I was curious about. So 100 times through 100 times takes 0.454. We're not even up to a millisecond yet. So Python is pretty quick. So is that in there for you? It shows loops, shows how you can count things, how many times something happens. It shows I guess, a fun sort of practical application of coin flips, and I just thought it would be interesting. A statistically interesting. And there is actually a function that allows you to time the code. I thought this is just a better way to do it, so you know how to deal with time. Then we have the final countdown. The assignment combines a for loop along with decision making. You're going to use a for loop to iterate through numbers 1 to 10. You could also do it with input too. For each number, if it's even, we want number whatever is even. If the number's odd, we want is odd. If the number is a multiple of 3, print that it's a multiple of 3. Use to D or to do or something, so I know that you understand what's going on. And you should end up with this. So we have loops, we have decisions. And get input from the user. I couldn't think of any other challenges at the time I was doing this. So how would you start this program? How have we started programs before? What's the first thing that you would do there, Mr. Andy? I'm just going to do it in Notepad because I'm not actually going to write the program because it's not that hard. Oh, that must be an example of a good password. Academy beats water bottle. I must have been doing that in cybersecurity. I'm guessing. All right, so how do we define the program? Well, it's already in here. The first thing I would do is copy this in and paste it, and work on the decision structure.
Oh, yeah, I'd probably mostly be using like a for loop to start with and then have a maybe if then for each within the for loop for each
So
number.
it would be if this, and then what would you do for the next one? Would you do a separate if, or would you do an elif?
No, I mean, if you're doing like three different options.
I'll take a look at the options, and one of the things that we have is exclusivity. Are they mutually exclusive, meaning we can only have one choice? Or can we have more than one of them chosen at a time? Can we have three different answers for the same number?
Because it could be a multiple of three and be even and a multiple of three and be odd.
Good thinking.
Yeah,
But can it be even and odd at the same time?
no,
Okay,
that one I'd probably do an if else, but
because it is either even or odd, isn't it? I mean, there's not anything in between. It's either even
Yeah.
or odd. Yeah, so you're doing good. It's either even or it's odd. And yes, mutually exclusive. Those two are mutually exclusive.
Yeah,
Meaning,
if it's multiplied of three, it's already odd.
that's a good thought.
Yeah.
Or you could just test it separately too, to see if it's a multiple of odd. Either way is a good solution.
So first we can check if it's multiply three or not. If it's multiply three, so it's multiply three, we can give the answer, and also it's odd. The next, we can make a next check if it's odd or even.
Or we could do even odd, and then in the odd, then we determine is it a multiple of three. So either way would work. But we have to treat them somewhat separately. Or separately, because they are separate. But one's mutually exclusive, meaning it can only be even or odd. Multiple of three means that it is odd, but it doesn't catch every odd instance.
Yeah.
So that's part of this, is figuring that piece out. The algorithm creation is the hardest part of programming.